Welcome everybody to this video on bubble sort. What we're going to be looking at before I get to the code in Java is kind of just an illustration of how bubble sort works, and also that sorting on a computer is not the same as it is in real life, since we can't look at the things we need to sort the same way we can as humans. So normally if I was a human, I would look at this and I go, okay, well, I know the 1 needs to go at the beginning, I know 3 has to go after the 2, I know 4 has to go before the 5, and 6 has to go after the 5. And I'd be done. I would have sorted the whole thing. But the difference is that as a human, I can look at my entire array here, or my entire list of numbers, and I can just figure those things out by looking at it as a whole. Now, the computer can't look at a list as a whole, it can only look at it element by element, or at most comparing 2 elements. So what we're going to do today is something called bubble sort. It is one of the worst sorts, but it is one of the best sorts for learning. So what we're going to do is look at how bubble sort works in a visual aspect, and then we are going to move into the code section afterwards. So the way bubble sort works is, what you're going to do is you're going to look at little bubbles, in other words, 2 numbers that are next to each other, and you're going to make a decision based on their orientation, not in the orientation of the whole list. Now, I know these are out of order because I'm going to be going from the lowest number to the highest number. So what bubble sort does is it says by this rule, and it will check 2 numbers, and if the first one is larger than the second one, it will swap them. Then it'll move on to the next 2 numbers. So 3 and 1. And it will do the exact same comparison. So is 3 greater than 1? If it is, we're going to swap them. And then we're going to look at the next 2 numbers. 3 and 6. Now 3 is less than 6, so we are not going to swap them, and instead we are going to leave those 2 numbers and move on to the next 2 numbers. Now we have 6 and 5. Since 6 is greater than 5, we are going to swap the 2 numbers, and then move on to the next 2. Since 6 is greater than 4, we are going to swap these 2 numbers as well. Now, we've gone through this whole thing once, and it does not look sorted. I have 2, then 1, then 3, then 5, then 4, then 6. But one number is sorted, and that number is my 6. So you'll notice that what's going to happen is each time we go through our numbers, that last number is always going to be sorted. Now, this also means that each time I go through it, I do not need to look at the previous last number because it's already sorted. So this next time, we're going to go through the whole thing again. So we're going to go back to the first 2. We're going to make our same check. Since 2 is greater than 1, we're going to swap. And then we're going to go on to the next 2 numbers. 2 and 3. 2 is less than 3, so I'm not going to do anything. 3 and 5. 3 is less than 5, so I'm not going to do anything. And then finally, 4 and 5. 5 is greater than 4, so I know I need to swap the 2 of them. Now, I'm not going to check the last 2 numbers because I know 6 was already sorted, and I know that through my last comparison, that 5 is also now sorted. In fact, if you look at the entire thing, the whole thing is sorted. That's great for us, but as I said before, our computer programs cannot look at the whole thing and find out if it's sorted that way. So, bubble sort will continue to check everything until it gets down to the last 2 numbers. So it'll go back, it'll check 1 and 2, won't do anything, then it'll check 2 and 3, then 3 and 4. It won't check 5 or 6 because we know those are already sorted. Then it'll check 1 and 2, check 2 and 3. Now we know that 3, 4, 5, and 6 are all sorted, so we check the first 2. You don't do anything, and we are done. Bubble sort is complete, it knows the entire thing is sorted. Okay, now let's look at the Java portion of the code for bubble sort. So to start, first we're going to create an unsorted array that we want to use with our bubble sort to test it. So I've created an int array here that has a bunch of random numbers. Some are even repeated. Bubble sort will still be fine with that. We just want to make sure that we have an array that is not already sorted. Next what we're going to do is we're going to start our bubble sort. So what I'm going to do is I'm first going to create a temporary integer This variable is going to be used only to do our swaps inside of our bubble sort. Otherwise, I don't care about it, so I don't need to initialize it yet. The second thing I'm going to do is I'm going to create my first loop. Okay, this is going to run through the entire loop from beginning to the end. This is what makes sure that we run our inner loop enough times. Okay. The second one that we're going to do, though, is we are going to run a loop that will start at the beginning, and it will go until the length minus I. Okay? Now this is important because it means that as I increases in our first loop, that's how many of our indexes are currently sorted at the end of our array. So we need to make sure that we subtract off those values so that we do not check them, since they should already be sorted. We are also using -1 because since we are always checking 2 elements at a time, one that is further ahead of the one we are currently on, we always want to stop one index earlier, since if we don't, we will get an index out of bounds error by going too far with that extra index. Next up is our condition. Okay, so we are going to swap our indexes if we know that our current element, so in other words, the element in our array test array, if j is greater than j plus 1, the element after it. If it is, we're going to do our swap. So first what we're going to do is we're going to say that our temporary number is going to be assigned to our current value, so our test array at index j. Then we're going to make test array j equal to test array j plus 1, so the next index, or the next element. And then finally, we're going to replace that next element, j plus 1, with our temporary number. And that's bubble sort. I'll print out the array at the end, and I'll run it. And it's sorted. So keep in mind, all I've done here is I've said, okay, I'm going to go through each single number, so I know how many numbers are currently sorted. In this case, the first time through it's 0. Next time through it'll be 1, then 2, then 3, then 4, etc. I'm going to start at my first index, and I'm going to go until the point at which I already know my numbers are sorted. In other words, the back end of my array, which has already been sorted on previous iterations of our loops. Then if I find a number greater than the one after it, I'm going to swap the two numbers. Now, as I said before, bubble sort is really bad. It takes a long time to sort compared to some other ways of doing this. What is interesting though is we can actually make this a little better. We can make it so that it'll be a little faster. If you will recall back to the visual example we used, the numbers were sorted well before my bubble sort ended. So what I can do is I can actually add a little condition that will make it so that my bubble sort will exit if the entire thing is sorted. And the way to do that is to introduce a new variable, which is a boolean, and I'm going to call it swaps. And this is going to check if the array is sorted by knowing if I had to swap anything on that iteration of the array. If I did not have to, then I know that it's sorted and I can end my code. So what I'm going to do is then before my inner loop each time, I'm going to make swap equal to false. So in other words, I'm saying I have not swapped anything yet. And then if I perform a swap, I'm going to change it into true. And after that inner loop ends, I'm also going to add another if statement that is going to say if swapped is false, this means we did not swap anything at all, and I want to end the loop. I will end the loop by making I equal to the length, so in other words, making my condition false, and my for loop will end. And if I run this, this will still cause it to be sorted by the end.